In the previous lecture, I have dealt about the special terms in kinematics. And in this lecture, I'm going to deal about motion with its deep concept. What is the meaning of these terms involving practical situation? So this is Shiksha Vinay, and I am going to deliver the lecture about kinematics, part 15. Now here, this is a chart. This chart is prepared from the data collecting by an event in which a man walks from his home at 12 noon. He starts at rest. And now, with the constant speed, in 15 minutes, he covers 60 meters along the straight road. And the next, at the time 12:40 p.m., he covers 160 meters from home, and at 1 p.m. it covers 240 meters from home. This is the 4 observations which are tabulated here. Now, there is some questions here. What is your speed? What is the speed of that man from 1 to 2, 1 to 2, and from 2 to 3, and from 3 to 4? And the next question I can give you from the same data is, what is the average speed in the journey, whole journey? And the next question I can give you, what is the velocity in this case? So how can you find it? How can you find it? It is simple. I am giving you some hint so that you can understand. From the given data or table, here I have drawn already a diagram so that you can understand easily what is going on. So at one position or at home, time is 12 o'clock, and at the place 2, time is 12:15, and so on. And the displacement from 1 to 2 is 60 meters, and 1 to 3 is 160 meters, and 1 to 4 is 240 meters. So I can say the displacement between 2 to 3 is 100 meters. Are you clear? Have you understood? And the displacement between 3 and 4 must be 80 meters. Isn't it? So From this observation, I can here write what I can get from this data. For 1 to 2, displacement is 60 meter and total time taken is 15 minutes. You can see here starts from 12 o'clock and end here at 2 at 12:15 o'clock. That means time during this motion 1 to 2 must be 15 minutes. So you already know that the rate gives the speed or velocity. Here speed is same as velocity, means because he traveled along the same road, along the same straight line. That's why the direction is fixed. So the magnitude of velocity also give the speed. So we don't need to bother about the direction of velocity here. And in the whole course of this lecture, we don't need to care about the direction, because we are dealing the straight line. Have you got my point? That's why the rate must be here speed or magnitude of velocity, or you can say in a rough way velocity. So either rate or speed or velocity is nothing but the displacement by time, or total displacement by time, or s2 minus s1 by t2 minus t1. Here s2 minus s1 is 60 meter and t2 minus t1 is 15 meter. That's why it is 60 meter by 50 meter. So we can simplify it and can get the answer as 4 meter per minute. You can change in SI unit also. You can change minute in second. You can solve it. Have you got my point? So he must have a speed 4 meter per minute during this motion from 1 to B. That's why he covers 60 meter in 15 minutes. Have you got my point? Similarly, you can find out for 2 to 3 and 3 to 4. Can you find it? Can you find? Of course you can find, because it is so easy. So from 2 to 3, the total displacement is 100 meter, and 2 to 3, the total time taken by the by the bikers is nothing but 25 minutes. Here you can see 2 to 3, t2 minus t1 means here time taken is 25 minutes. Have you got my point? That's why I have written here total displacement is 100 meter and total time is 25. So the rate must be, or speed or magnitude of velocity, or you can say velocity is nothing but total displacement by time. This becomes 4 meter per minute. So here you also get the same result as before. And similarly in the case of 3 to 4, you can get the same answer as before. So what conclusion you get from this observation? Obviously, in all the cases, the speed is same. So we can say the man must walk with uniform speed, uniform velocity, or fixed velocity or constant velocity, which is 4 meter per minute. Have you got my point? This also gives the idea of instantaneous velocity, because at every point its speed is 4 meter per minute. This also gives the idea of instantaneous velocity. Now the next question is, how can you get average speed or average velocity in this case? So it is simple. Average always taken for whole thing in physics or in science or in mathematics also. That's why we are now covering whole journey from A to 4 for average, because we have to find out average speed. That's why we are taking the journey from A to 4. Have you got my point? So from 1 to 4, the total displacement is nothing but 240 meter and time is 60 minutes. So you can find out this also must be 4 meter. This is also so strange. Why average speed is also come out with the same result? Why is it not different? Why it is same? Because the speed is constant and the man walks along the same road. This is the two reason. That's why the average speed is. For example, if I give you 6 times, then what is the average of these 6 5s? So what would you do? That the average means that the sum of data by number of data. Here number of data is 6 and the sum of data is 5 plus 5 plus 5 plus 5 plus 5 plus 5, 6 times. So it becomes 30. So if you want to get average, so 30 must be divided by 6. So you get 5. Have you understood my point? That means if the data is same at every point of instant, then the average is same as given before. That's why in this case speed is same at every point. So average speed is also the same value as the instantaneous value, as I already told you in the previous lecture. If you observe it, you can understand. Okay, that's why I am written here. Instantaneous is nothing but average if the motion is along the same straight line and with constant speed. Constant speed or velocity means a body covers same distance for a same interval of time. If it covers in 1 minute, it covers 20 meter in 1 minute, then in any other in any other places it must cover 20 meter in 1 minute. So if time interval is same, the displacement covered by it must be same. Then we can say that the speed or velocity is constant here. So we can say if an object covers equal distances or equal displacement in equal interval of time, then it is called uniform velocity or constant velocity, or this motion is called uniform. Otherwise it is non-uniform or accelerated. So in this case magnitude of velocity is equal to speed. Have you got my point? Why it happens I have already told. Because the direction and the instantaneous velocity is same. That means data is same for every point. That's why average is also same. And here magnitude of velocity is nothing but the speed, because here direction is always fixed. If he walks in the direction of east, it means he walks at every point in the direction of east. That's why we don't bother about the direction. So we only bother about the magnitude. And magnitude of velocity is nothing but speed. Have you got my point? So here a speed can be replaced by velocity. So average velocity or magnitude of average velocity, or we can roughly say the velocity is 4 meter per minute in this case also. Have you got my point? So I am right here. Now my question is, can you find acceleration in the whole journey? What is the acceleration in this case? Can you find it? What is acceleration? Acceleration is nothing but the change in velocity with respect to time, or you can say the change in velocity in 1 second or 1 minute or 1 hour, whatever your unit is. So what is the change in velocity or speed here in 1 second or in 1 minute? Surely in this case there is no change in velocity. That's why change in velocity is nothing but 0. So acceleration is here 0. Have you got my point? So there is no acceleration at all in this case. That's why it is called non-accelerated motion or uniform motion, because here speed is constant, velocity is constant, and there is no acceleration at all. That means if there is constant velocity, means acceleration is 0. It means v and u is same in this case, because v is also a 4 meter per minute, u is also 4 meter per minute. That means both are same. That means their difference is 0. Have you got my point? Now I give you a second case for your thinking. Now I am changing some data. This data is same as previous case, and this data is also same for as we discussed in the previous case. But here I am I am here change the time, and I am here also change the time. I am not changing the displacement, but I am changing the time here and here for the case at 3, for the case at 4. Only 2 changes I have done in this case. So what will happen? What would be the answer as I have already solved in the previous case? Are the answers same, or it may be different? Let us see. Let us see first question I will give you. So find the speed from A to B, 2 to 3, 2 to 3, 3 to 4, average speed, magnitude of average velocity, and the fourth question is magnitude of average acceleration in the whole journey, and the fifth question is magnitude of acceleration from 1 to 3. Now you have noted the question, the 5 questions. The first question is find the speed from 1 to 2, 2 to 3, and 3 to 4. And the next question is average speed. Third question is magnitude of average velocity. And fourth question is magnitude of average acceleration in the whole journey. And the fifth question is magnitude of acceleration from 1 to 3. Can you solve it? I am here left it out for you. So try it home, do it yourself, and answer is here I have written. So you can match your answer from this. If you face difficulties while solving your problem, then you can contact Shiksha Vinaya or mail me or comment on my YouTube channel. I am surely give you the answers. Now you have grasped some idea about how to calculate average velocity, average acceleration, average speed, or acceleration at a point, or acceleration between two places, velocity between two places. So now I am giving you the important types of. There are two important types of motion here. One is uniform and second is non-uniform. I have already told you what is the meaning of uniform and non-uniform. Uniform actually means same, and non-uniform simply means not same or unequal. So if I say uniform motion, which quantity is same here? It is simply speed. That means in uniform motion, speed is same. But in non-uniform, speed or velocity is not same in your case. So I have already told you, if speed is same or velocity is same, that means an object travel equal distances in equal interval of time. If it covers 20 meter in 5 seconds, and then it in every 5 seconds it also covered 20 meter, then its velocity or speed is same. Otherwise their speed is not same. Have you got my point? So I have already give you example for the glimpses of this kind of motion in case 1 and for non-uniform motion in case 2. So for case 1, the motion is called uniform motion or non-accelerated motion because acceleration is 0 here because the velocity is same everywhere. And this kind of motion is called non-uniform accelerated. We will deal it about it in greater detail. So I am writing here acceleration is 0, but here acceleration cannot be 0. It may be negative or positive, but cannot be 0. It has some acceleration. Whether it is negative or whether it is positive, it doesn't matter. So you can, in other words, you can say here speed never change or velocity never change. But here in this motion, acceleration speed must be changed. And when the speed change or velocity change, acceleration comes every time. Have you got my point? So we can say that here change in velocity or speed is 0, but here change in velocity is not 0. Have you got my point? So we can symbolize it as del V is equal to 0. Del means change or difference between two quantities. Here V means velocity or speed. So V2 minus V1 is equal to 0, yeah, or V final minus V initial is 0, or V minus U is 0 here. But here not 0. So V minus U is 0. V is equal to not 0 here. So here you can solve it by V equal to U. It means at every place speed is same or final speed is same as initial speed in this case. So it is called constant speed. But here a speed or velocity changes, means maybe faster, maybe slower, it doesn't matter. Have you got my point? So in this lecture we are necessarily we have dealt about the uniform and non-uniform actually, and I have given you some greater detail about uniform and non-uniform motion. Have you understood all my points I have teach you in this lecture? Now in the next lecture I'm going to discuss more about how can you solve the problems involving this kind of motion. But before this, I am giving you a task. You must try at your home for your deep understanding of kinematics. Can you draw a graph of case 1 and case 2? Just simply you have already studied about the graph in previous class that you have to take a y-axis and the x-axis. At x-axis you have to take time, velocity in third case, and y-axis you have to take distance in first cases and velocity for second cases and distance for third cases. And from the given information which you have already solved about it from case 1 and case 2. You have to take several points on the graph or several coordinates. You have already studied coordinate system. Have you got my point? So if you got at least 4 or 5 points, then you can join it by rough hand, smooth end, and we got the graph of distance versus time, or velocity versus time, or distance versus velocity in these two cases. So there must be 6 graphs, because for case 1 there is 3 graphs, and for case 2 there must be 3 graphs. You have to plot it. Have you got my point? Yes, it may appear difficult, but if you try, your mind must be broad, and you feel confidence about that I have done some great job. Have you got my point? And in this way your physics or science becomes stronger and stronger, because your thinking skill or brain power becomes strong and strong. After trying, if you face difficulties or if you troubled about it, you can contact Shiksha. I will help you, or Shiksha Vinay must help you. Thank you for watching.